Hi everyone, I'm Dr. Surjit Singh. Today we will talk about the Leetcode problem minimum window substring. Welcome to the video. Let us begin. Given two strings, we are to find minimum window of 1 in which every character of 2 is present. Multiple characters are allowed. We will follow the sliding window approach. We are given two strings S and T. We are to find the smallest window in S which contains all the characters in T. If one of the strings is empty, the result is also empty. We save counts of characters in T in the dictionary named tcount. We compute required, which is number of unique characters in this dictionary. In this example, there are three different characters in T, namely A, B, and C. So required is 3. We define another dictionary named winCount, which will store the characters present in the selected window, and it is empty to begin with. We use the left and right pointers to define a window contained between these two pointers. Both left and right are 0 to begin with. Formed is a variable that counts the characters present in T that have also been put in winCount. It is also 0 to begin with. We define a tuple named out, initialized to infinity none none. It will be used to save the details of the output window. Next, we start a loop on write and iterate over string s. Ch is character at write. When write is 0, ch is a. Count of a in winCount dictionary is increased by 1. So count of a becomes 1. Character A is also present in tcount and its count is same in both the dictionaries. So formed is increased by 1. As formed is not equal to required, the while loop is skipped. Write is increased by 1 and the next iteration of outer loop now starts. Character at right is D, which is added to Win dictionary. D is not present in tcount, so formed is unchanged and the inner while loop is skipped again. Right becomes 2, character at 2 is A, so count of A in Win count is increased to 2. A is present in tcount, but its counts are different, so formed is not changed. Formed also not becomes equal to required, so the while loop is skipped. Right becomes 3. The character there is B, which is added to win count. B is present in T, but its counts are different, so formed is unchanged. Right becomes 4. The character there is E, which is added to win count. E is not present in T, so if is skipped, and then while is also skipped. Right becomes 5. The character there is C, which is added to win count. C is present in T and the counts are same in the two dictionaries, so formed is increased by 1. This indicates that work for A and C is complete, but for B it is incomplete. In the next three iterations, O, D, and E are added to win count. Now right becomes 9. Character there is B. Its count in win count becomes 2, which is equal to its count in T. So formed is increased to 3. At this stage, formed is equal to required. This means that all the characters of T are contained in window between left and right. Now we need to save the parameters of this window. We enter the inner while loop and check if we should save the parameters of the window. Currently, index 0 in out is infinity. Length of the window is right minus left plus 1, which is less than the current value in out. So we modify out as 1009 as the best result so far. Character at the left pointer is A. We reduce count of A in win count. It becomes 1. The required count of A is also 1. So no worries. It is not less than T count of A. So the next if is skipped and the left becomes 1. As we are still in the inner while loop, it means that the window is still a valid solution even after removing one A. Another is still present within the window. But the length of the window has reduced, so now we will save the revised parameters, which are 919. Character at left now is D. We drop it from the window, so we reduce the counter of D to 1. D is not in T count, so if statement is skipped. Left becomes 2 and the next iteration starts. There is a further reduction in the size of the window, so out becomes 8 to 9. Character at 2 is A. Next, count of A is reduced to 0. A is present in T, but its count in win count has gone below the required value. So formed is reduced by 1 to become 2. Left is increased by 1, formed has gone below required, so the while loop terminates. Outer loop will move right till another A is found and formed becomes 3 once again. Right becomes 10 where character is A, so count of A in win count becomes 1 once again and formed becomes 3. This means that contraction loop will start once again. Length of new window is same as that of old, so out is not changed. Character at left is B, count of B is reduced to 1 in win count and formed reduced to 2. Left becomes 4 and the loop terminates because required is not equal to formed. Outer while loop will shift right pointer till another B is found. It means O and B are added to this list. Formed becomes 3 and the contraction loop starts again, in which E and C are removed. Formed becomes 2 once again. Length does not come below 8, so out is unchanged. Final value of left is 6. Right becomes 13, where character is C. C is added to win count and formed becomes 3. A new phase of contraction starts. Counts of O, D and E are decreased in win count. Formed remains 3 as left becomes 9. At this stage out is 5, 9, 13. Character at left is B. Count of B in win count is reduced to 1 and formed is reduced to 2. Left becomes 10 and right becomes 14 and the main loop terminates. Substring of S of length 5 from 9 to 13 is returned as the answer. However, if length is infinity, an empty string is returned. Both left and right move across the elements of S, which has length m, while t count is formed in time n, so time complexity is of the order of the greater of the two. Extra space is used for t count and win count. In this modification of the original method, we filter out those characters of S which are present in T. Initial steps in this solution are similar. We now define a list called filtered S. We scan all the positions in S and look for the characters present in T and append the pause character tuple in filtered S. We skip D as it is not in T and save pause 2 with A and 3 with B and so on. Instead of scanning all the characters in S, we will only scan the entries in filtered S. In the first iteration, right is 0, count of A becomes 1 and is saved in win count. The counts of A in win count and T count are equal, so formed is increased by 1. Formed is not equal to required, so inner while loop is ignored. Right is increased by 1. In the second iteration, counter of A in win count becomes 2. In the next iteration, B is added to win count, but its counts are not same in win count and T count. Next, C is added to win count, and its count is equal to that in T count, so formed becomes 2. When right is 4, another B is added to win count. Count of B are equal in win count and T count, so formed is increased to 3. At this point, formed has become equal to required, so now we enter the inner while loop. Positions at left and right in filtered S become start and end in window. So start is 0 and end is 9. Length of window was initialized to infinity in out. The new length of the window is lesser, so we modify the values in out. The character saved at position left in filtered as is A. Next we reduce count of A in win count by 1. It is still equal to the count of A in T count, so formed is unchanged. Left is increased by 1. In the second iteration of inner loop, left is 1, start is 2 and end is 9. Length of the window is 9 minus 2 plus 1 equal to 8. So out becomes 8 to 9. Count of A in win count is reduced to 0. Formed is reduced to 2. Left becomes 2 and the inner loop is terminated. Right is increased to 5. Count of A in win count becomes 1 and formed becomes 3. The inner loop starts again. Length of window remains 8, so out is not changed. Win count of B becomes 1 and formed becomes 2. Left becomes 3 and inner loop is terminated. Right becomes 6, count of B in win count becomes 2 and formed becomes 3. Length of window remains 8, so out is not changed. Win count of C is decreased to 0 and formed becomes 2. Left becomes 4. Right becomes 7 and win count of C becomes 1. Formed becomes 3. Out becomes 5, 9, 13. Win count of B is decreased by 1 and formed becomes 2. Left becomes 5. Inner while loop terminates. Right becomes 8 and outer loop also terminates. Final window is from 9 to 13 as stored in out. So BAOBC is returned to the main program. Both time complexity and space complexity are unchanged. However, if filtered S is far smaller than S, there is a considerable reduction in execution time. Thank you for your time and for watching the video. See you in the next video.